Hey everybody, my name is Sean Fruin. I'm the mechanical project owner at IMEG, and today we're going to talk about automating SD narratives with large language models. So let's hop into it. So first, what is a design narrative? For people who don't might know, design narrative is something that you put together typically for an architect or even the building owner that is a story of kind of telling what the design assumptions are, what the basis of design is, and some of the assumptions that you're doing in the building. So I've never really liked this process. I'm very dyslexic. And when I've had to write these, it just wasn't a fun thing for me to do every day. And I always pictured that this could be automated, but it wasn't really possible until recently with the advent of large language models. So I think there's a pretty big opportunity here. I don't think I'm the only one. I think, it could help a lot of us. For example, we can take all the data that we have inside of our project and get it into the narrative, no longer having to transfer data back and forth between different applications. We still give the end user manual control at the end. So there's all upside for the end user. They just get the automated part, but if they still want, they can go ahead and edit that. I also think that there's a big learning opportunity here. The large language model has a lot of resource files in it and everything. So you can actually play around with the large language model, talk to it, and actually learn from it. So I think this is a really good opportunity for even more younger engineers coming up to have a chance to almost have a mentor, but really it's just a knowledge base in the background. Then of course there's the time savings. So we went around and asked a whole bunch of engineers how many hours we think it would save them, and you got about an average of 4 hours per project. And of course, depending on the project complexity, there's also a whole bunch of different types of narratives, some more complex like the system comparison ones, but overall, we're going to say 4 hours per project. So next, there's the benefits then for the organization, not just the individuals. So I think there is a huge consistency thing here. So if we look at these two graphs at the top of the image, right, if everyone's writing their own thing, using a Word document template, we're going to have a very large variance in the documents that are coming out. Right, when we use this language model approach, we're going to have a lot more smaller variants. Hopefully it's a good end product. I think it is. But again, the consistency, clear formatting, all that is huge across the organization. With IMEG, we have a whole bunch of projects, a whole bunch of offices, so that's huge. There's also scaled knowledge. So again, we have all these documents in the background of the large language model that really let us control some of the knowledge and scale some of the knowledge across the firm. So that's huge. And then again, we already kind of talked about it. The efficiency goes way up just because we get cut out a whole bunch of the data transfers, manual transfers. Some senior engineers don't even get into the Revit model. So that's huge. And then again, the time savings for the firm is pretty big. So something really cool at IMEG, when we do automations, we have so many projects, it really scales quickly. So if you take that 4 hours per project, multiply it by 3 trades, right? We're looking at, with 2,000 projects per year, $50 an hour. I think all these numbers are kind of moderate. We get over $1 million in savings. So pretty big deal. So that's what we're going to talk about for the rest of our time together. We're going to go over a quick demonstration of low code. We're going to look at the building blocks of the ChatGPT, and then quickly look at some current and future visions for this and some of the challenges and solutions that we had to overcome. So to the low code demo. So we're going to take some information from Revit. We can actually use the AEC Data Model JSON format to feed it into large language model. We also have an output from OpenStudio, Energy Plus, all from Revit. It's an HTML format. That's going to go into the large language model, and we're going to write the design narrative. So right off the bat, for this workflow, right, it's really early in kind of SD schematics, and we have this wonderful workflow that lets us trace around a building really quick, right? Minimum effort, high impact on the outputs, very detailed, and really all the inputs that go into the narrative are here. So here we're setting, those design criteria, the U values, the location, all of those assumptions are now inside the Revit project. And we can then utilize that later. Here we just create the energy model and defining our systems, which is critical for doing like the system comparison narrative and everything. And then we're going to run the simulation, and now we get this HTML output that then we can also feed in that has a wealth of information and data for writing the narrative. So this workflow is about an hour, maybe even shorter. And again, the detail that you get out is so nice and very rich and has everything that we need to write the narrative. Here we're looking at some of the carbon capture stuff. All right, so then once we've run that analysis, let's have that. We can go ahead and get those data sources. For this low-code version, we're just uploading those data sources to our chatbot that we built. And then we're saying, hey, go ahead and run the narrative. So it goes through, runs the narrative. First pass on it. There is a nice feature in the ChatGPT where we can go ahead and start to edit that. So now I'm prompting the large language model, say, hey, can we edit this in Canvas before our final pass? So maybe something wasn't quite right in the narrative as I went through. Here I can go ahead and say, oh yeah, those code years weren't quite right. I'm going to go ahead and edit those. Now I'm going to get a final pass to make sure it picked up any formatting or spelling errors, again, dyslexic, that it might have. And we get this wonderful output. Next, I'm going to say, okay, this is great. Now, can you output me a Word document? And of course, we're going to follow that IMake standards. And here we go. It's going to take a Word document from within the agent, write all the code. I've actually become a better coder through using these large language models. Like I didn't know how to write the code to make a Word document, but out we have the document, we can download it, and there's our narrative. All right, so now let's go take a deeper dive into the building blocks of this agent and how to prompt it. It all is about prompt engineering and getting really good prompts. So let's dive through that. So there's, you put a name, description, but most importantly, we have instructions, step-by-step details. The knowledge base is crucial, and then custom actions is also crucial. Let's cover the custom actions real quick. Notice we're letting it search the web to maybe get some more knowledge. We have the canvas for editing. We have DALL-E for image generation, for graphics, tables, stuff like that. And then the core code interpretation and data analysis really lets us build those graphics and everything. Everything I talk about here, you can get in a lot more detail in two sources that I've found in OpenAI. So go ahead and scan those. I'm going to go through kind of these instructions pretty quickly. And with the narrative mindset, this is more generic, but go ahead and scan that for your reference. The other big thing I want to mention too that I've found, and this is in those documents, is using Markdown in the instructions is really important. So when also writing the instructions in the knowledge base, I feel like it's kind of a chicken and an egg thing. What comes first? Do you write the instructions, but then you have to reference the instructions with the knowledge base? So you should write the knowledge base first. I'm going to go ahead and say, let's start with the knowledge base. So we're here. I'm going to run through some of the building blocks of the knowledge base. We have examples, so pre-written narratives. We have instructions, step-by-step, kind of sub-instructions, support data, style guides, and then our template. So examples, we actually took a narrative that's already been written and we converted it into the Markdown format. And again, this is because the large language can follow it, but that's one of the things. We have a few different examples within the thing that the large language model can go and reference and kind of read and get the tone and style and layout and all that. For the instructions, we have sub-instructions in here. So this is where we're really identifying, hey, go look at the GBXML, and for design assumptions, go here. To do the portion that's about location, go into this GBXML and this specific function of the GBXML. For the system metrics, here we have a whole bunch of pros, cons, different assumptions. So we have instructions in here to go into this data source and grab kind of some of the wordage, pros, cons, and be able to put that into our narrative. Style guides, we try to outline all the different fonts that are standard to IMake. We have all the colors in there. Again, this is just reinforcing, hey, follow these formats whenever you output the final document. And finally, the best way that I've found to get like the imagery, like the IMake logo and the exact fonts is to actually feed it a copy a Word document and actually have it just replace the pieces of the Word document. So the next thing that we want to do is look at the GPT instructions. This is where we're going to go step by step, kind of tell it to take stuff out of the knowledge base and what to do with all the stuff in the knowledge base. Again, right, it's really the brains of how the large language model is working, where we kind of have these different sections, and we're going to go step-by-step goals. So if I open this up in here, right, the instructions get really long. Notice they are all in Markdown, and we're going step by step. You know, we have section 3 and then all these subsections. So it's really like the kind of building a peanut butter sandwich. Let's walk through step by step what we want this thing to do, but yet we're using human language in our code. So just to run through this, right, I like to give it a base context. Hey, what's this all about? Kind of give it an overview. Like your role is to write technical documentation from Revit stuff. Be clear, be professional. I like the no emojis. Another one I like in here is the free of hyperbolic language. I can always identify something that's been made from a large language model because it's always revolutionary or it's just this silly language. So I found that one to work. One that one of my developers shared with me is no chit chat. So there's all these little quirky little things you can put in here to really get what you're looking for. So then we give it a role and purpose. Hey, you're an engineer, you're an expert in this. You know, always follow instructions. And then we get into the step-by-step instructions. I didn't want to write it all here, but I did just want to kind of give an overview of how it looks. So notice we have the big headers with review knowledge, do this, ... There's some steps in there, but then second, craft the response, and then that has subtasks in there. And again, this all builds out to be a pretty big document when we're done. The other thing too is we mentioned this a little bit because we have subsections, but again, trying to say, you know, data source guidelines, hey, go to this exact file for this exact portion of the design narrative. And then we go into the format instructions. And then one of the biggest things is just keeping these things on the rails. And we've done that by, you know, really breaking down all these steps into, or all this complex process into small steps, and then giving it really big outlines on exactly what to do. So for a future version in iMeg, we are actively working on this. It is a moving target, work in progress. And what our vision is we actually have an internal chatbot that, you know, only looks at our data. All of our users have access to it, so no one has to pay for ChatGPT, for example. And with that framework, we are building out these agents. This is what this kind of looks like. So seamless integration, what we are looking to do is starting to build out our own database for each project. And then we can actually upload some of these files into the database. Another interesting thing about this that we're working on is kind of going the other way, where we're taking the structured data, large language models in the middle, and it's actually starting to populate, you know, these design assumptions. And then what our agent is actually going to do is look at these different cards to write the different sections of the narratives. And then also a future look kind of gets into the, you know, Autodesk platform surfaces. I think it's, with all the APIs and everything, it's a good foundation for building on top for all this stuff. So again, we can take stuff through these APIs from the Revit model, trigger the OpenAI APIs, and kind of do it all integrated through Autodesk platform surfaces, which is pretty cool. Something we're exploring. And then also what I picture in the future is just this narrative timeline where, you know, we have all this data. Anytime in the process, we can produce a narrative at these different stages, hand off. They can be dynamically updated. So it's really exciting there and pretty ambitious, but I think we're pulling it off. So some of the challenges, right? We don't want these things to hallucinate. So some of the things we've overcome. One of the things we've noticed with developing our own chatbot in-house is it feels like it's a year or so behind where ChatGPT is. So we've built some bots that are really awesome, then converted them back to like our internal bot and doesn't quite work so good. So just keeping up with all the changes because everything's moving so fast has been a struggle. Too many tokens. I think this is going away with the new, bigger, large language models, but to combat the too many tokens idea, again, writing really implicit directions about, hey, going here, taking data from here for this section. So really trying to keep it on the rails like we covered. But yeah, all this is coming down. And just to recap, right, we took exported structured data. We then prompted the LLM to generate the narrative, reviewed, refined for the human, and we get our final product. If you're going to do this on your own, I would take baby steps, start small, build up, and you'll get there over time. And 3 takeaways from all this, if anything, in this quick 15-minute presentation is, 1, structured data and large language models is a very powerful thing. One of the things we've discovered last year. So combining those two is way better than just randomly prompting something. Agents, again, are a firm's knowledge base. We have all those resources in the agents, so we can start to actually really scale up knowledge across the firm. And everything is evolving so fast to stay ahead. Always got to keep learning, always got to keep adapting, staying agile. And that's it. Thank you.